Hello, I'm Corinna Breitinger. I'm a doctoral researcher with the University of Konstanz and the University of Wuppertal in Germany, and I'm going to present to you our JCDL paper titled Visualizing Feature-based Similarity for Research Paper Recommendation. First, I'll introduce the problem that our research paper sets out to solve, which is we found that current literature recommendation systems and interfaces do not support the discovery or exploration of non-textual features contained within academic papers. So this includes citations, charts, tables, images, as well as mathematical formulas. And second, I will introduce our visualization concept that for the first time does consider these text-independent features in a paper recommender system, which we call RecVis. And finally, I will briefly discuss the user study we performed and the results. So all researchers are quite familiar with research paper recommender systems. Here we have two examples of recommendations generated within the ACM and the IEEE digital libraries. However, these simple list-based recommendation interfaces, they lack an explanatory and interactive exploration of the recommended items, and also any contained article features within the recommendation set, so features that go beyond the title, venue, or the author names. They cannot be discovered, so they can only be discovered by the researcher if the researcher puts in the manual effort to read the entire full text of the recommendations, and then these features become evident. But that, of course, takes a lot of manual effort on the part of the researcher. So we looked at interactive interfaces that currently exist for recommender systems, and we found that none of them have addressed this problem of supporting non-textual feature discovery within research papers. However, in our paper, we do review all of these existing interfaces, both for the paper recommendation use case and also for other use cases, such as recommendation of music or the recommendation of academic talks. In our paper, we then summarized the status quo, and we found in this table, we found that in the case of the recommender system domain, a detailed visualization and comparison of non-textual content features has not been examined. And also, this has not been examined for other domains, such as music or research talks. However, in the domain of similarity detection, specifically for plagiarism detection systems, such features within the documents have been analyzed, and thus we make use of methods from this domain of plagiarism detection and apply these in our proposed system to improve research paper recommendation. In a previous publication at JCDL, we described in detail the implementation and the system architecture of our RecVis paper recommender prototype. So for that background, it can be helpful to refer to that publication. In that paper, we also discussed the similarity measures used by RecVis, and we introduce this graph-based layout, which we can see here, that gives an overview of the recommendation set, and it also enables a user-customizable filtering of the recommendation according to the researcher's information needs. But now in this paper, after having reviewed the state of the art in recommendation interfaces, we then focus exclusively on the visualization of these currently ignored content features contained within research papers. So here we can see 4 user-customizable feature comparison views that we proposed for visualizing the similarity of keywords, the similarity of figures, charts, and images, and in the bottom row, the similarity of citations and mathematical formulas as well. Now, to evaluate these feature views, which are especially useful for STEM domains, so science, technology, engineering, and math, because of these non-text features, we performed an expert study with 10 researchers, and the objective of this study was to assess whether the individual feature-based views could allow for an effective exploration of the content present in the recommended literature. And for the method, we measured task completion for a set of 14 information retrieval tasks. We also collected survey data and used the standardized post-study systems usability questionnaire for reproducibility. And then for the results, we found that the information retrieval tasks, the participants on average had a successful completion rate of 95% across all tasks, and the completion rate ranged between a low of 70 and a high of 100% for 9 tasks out of the 14 tasks. And we found that these results were very encouraging, given that none of the specialized information exploration tasks, which we defined in our paper, would have been supported by the existing visualization interfaces of paper recommendation systems. So lastly, I wanted to highlight just some of the responses we received for the survey questions on the feature exploration views. For example, nearly all participants either strongly agreed or agreed that the citation view let them quickly compare the results of citation matches. Also, highlighting the citation matches helped them identify the relevant passages. And the figure view allowed them to quickly compare figure matches or potentially relevant figures, as well as in the case of formulas within the academic papers. They said that highlighting similar or identical identifiers helped them judge the similarity of the given formulas. So in conclusion, the results of this evaluation with experts show that the interactive interface we proposed really can support the user in more quickly identifying specific features of interest. Of course, this is especially helpful to answer specialized information needs that existing recommender interfaces do not support. And in summary, our study and the visualizations we implemented and evaluated in RecViz can give actionable insights to both researchers and practitioners who are building and improving academic literature recommender systems. These are the references I cited earlier, so you can pause the slide if needed. And if you have any questions or comments, feel free to reach out to me. Thanks for listening.